Today, I'm going to present our group assignment of electronic device and circuits. Today, we're going to talk about AC to DC power supply. Our team is consists of 4 persons, which is me, Lojaya, Ahmad Shafiq bin Muhammad Nasir, Izzatul Najwa binti Natia. So rectifier. What is a rectifier? In order to convert AC signal to DC signal, we need a rectifier to convert AC into DC. A rectifier is made up of a diode. A diode limits the current to flow in one direction. So for different combination of diodes, it's going to form a rectifier, which can convert AC signal into a DC signal. So there are a few types of rectifier, which is half-wave rectifier and a full-wave rectifier. For the full-wave rectifier, there's 2 types of full-wave rectifier, which is center tap full-wave rectifier and a bridge full-wave rectifier. Now, let us look at the connection of the circuits of the bridge full-wave rectifier. This is the circuit of the bridge full-wave rectifier. Take a look at here, which we have a power supply of 10 volts and the frequency of 1 kilohertz. And the power supply is connected to the diode, which have diamond-shaped connection. And there are a few types of oscilloscope putting at different places of the breadboard to observe different waveform of the circuits. Now, if we look at the initial voltage, we are measuring the AC signal before it is getting rectified. And after rectification, we look at the waveform of the rectification and the filter waveform. From now, we can observe that the signal has been converted into a streamline method of the signal. And then the signal is not really consistent yet, because the reason why that it turns from AC into DC is because the current flow from the power supply to each of the diode. And for the diode, there's only 2 diodes which are going to allow the current to flow in one direction, and the other two diodes, this blocking the current to make it not flowing into the other direction. So it makes the AC signal to flow in one direction. And the function of capacitor is to add filter to voltage. When the voltage is decreasing, and the capacitor is getting charged, when the voltage is decreasing, the voltage of the capacitor will be used to fill in the decreasing voltage of the waveform. And finally, a Zener diode is also added to regulate the voltage. To regulate the voltage, a Zener diode is set in order to make the filter really smooth, to have a really smooth line. So here's the simplified diagram of the bridge full-wave rectifier. As you can see, there are two directions of flowing of the current. For the green line is when the current is flowing in one direction, and the red line is when the current is flowing in the other direction. And you can see now there is ripple here, and then there is chart. Here's when the voltage is decreasing, the capacitor when it is fully charged, it will provide the voltage for the circuits, and it's keep on decreasing. And as the voltage increase again, the capacitor will be charged again, and then repeat the process. Now for the calculation parts. So in order to find the peak voltage, we have to use the Vs minus 2 Vd, and we get the value of 3.6 volt. And to find the ripple peak-to-peak voltage, we use Vp over 2 FRLC, which is the formula of peak-to-peak voltage, ripple peak-to-peak voltage, and we get the voltage value of 0.215 volt. And for VDC, we use Vp minus half VRPP in order to find the VDC. And the VDC is 8.495 volt, and Vp minimum is Vp minus VRPP, which is V peak minus V ripple peak to peak voltage, which is given the value of 8.386 volt. And finally, to find the minimum resistance, we use 8.395 minus 4 bracket divided by 1 kilo to find the value of R minimum, which is 910.125 ohm. And the resistor used in the circuit is 1 ohm, and we set the Zener voltage to 4 volt, and hence it's going to produce a constant output voltage of